I'm going to go ahead and answer 89. This problem was asked from 232. Find the domain of the given function, and we're going to do this algebraically, really by looking at the denominator. The whole goal here with the domain is all real numbers will work unless the function's undefined. Well, how's a function undefined? This bottom part would have to equal 0. So, the easiest way to do this is to literally set up the equation. X plus 2 equals 0. Subtract 2 from each side. X equals negative 2, which actually means when x is negative 2, you get 0 in the denominator, which means it's undefined. So, the domain here would be negative infinity. Domain negative infinity to negative 2. Open parentheses because it doesn't hit negative 2, in union with negative 2 to positive infinity, or all real numbers except for negative 2. So x cannot equal negative 2. So that's A. B is very similar. Well, actually, B is a square root function. Square root of 3 minus x. Well, you know the square root function looks something like this. Okay? And you can't have negative in the square root. So again, we'll set this equal to 0, 0, and actually let's just set this part equal to 0. I'll go ahead and add x to each side. 3 is equal to x. Oops. So in order for this to be true, x has to be less than 3. Because the moment it's greater than 3, this whole thing is a negative number. So, if x is less than 3, we would write the domain as negative infinity to 3. And actually, it can hit 3. So, there would be our domain, because then it would just be 0. Let's look at C. X squared minus 4 over x squared minus 1. Got to factor this one out, so it's x plus 2, x minus 2, all over x plus 1, x minus 1. So again, like in A, x cannot equal 1 and negative 1. So if you want to write your domain, interval notation, negative infinity to negative 1, in union with negative 1 to 1, in union with 1 to positive infinity. It breaks at these two values. Okay. And then D, it's a cubic. There's no breaks in it. So because of that, it is all real numbers. Or negative infinity to positive infinity. Alright, I hope that helps with that one.